Hello. This presentation is by Lukasz Pryzbos and myself, Brandon Davis. So for our project, we chose the language Vala. I'm sure from the title, you get a hint of why we said bootlegged, but actually, Vala adapts from the languages Java, C#, and C++. Of course, it has its own perks and feelings to it as well. So let's begin. Vala was originally developed by Jurg Bieliter and Raffaele Sandrini, whom are contributors to the GNOME project. Vala is an object-oriented language, like many of the popular and commonly used languages today, such as C# and Java. It is also multiple paradigm, meaning that it has many ways of building itself. Vala supports features of modern languages, such as for each loops, interfaces, lambda expressions, and type inference. These modern features also includes parallel programming techniques, like multi-threading. If we had to categorize Vala, we think it would lie somewhere in between C# and Java, since it shares many of the abilities of C#, while still having a writing style like Java. One thing that holds back Vala from being at the same level of a language like C# is how it handles racing conditions. The main suggestion is to use locking, but from class, we know how slow that can make a program.
So Vala is actually compiled into C code. And we know the restraints that C has, and that's pretty embarrassing to a certain degree. Luckily, the developers have their own added libraries and classes in order to stand by C#, as well as integrating other open source written libraries such as GTK+, which is where GUIs can be run through Vala. And basically the optimization here is that VAPI works with Vala to create the code that gets compiled and then makes the executable. So we can look at that with this example where I have a virtual box of Ubuntu set up, and clear. So if we do GUI.vala, here's our code, and we have to include GTK up top, and then we have to initialize it, and basically we have our setup, our parameters, etc., etc. Now we want to compile that, so we have to do vala c minus package GTK plus minus 3.0 GUI.vala. And then it'll give us an error about a deprecated value in C, but that's not our concern. And then we run GUI. Ta-da! And now we have our hello world, pretty as can be. So now if we wanted to look at the code for that, we would do the same thing. Instead of letting it just do its thing, we want to do minus C as a flag so that it knows it compiles into just C. And then it'll work. And then we do vim GUI.c. And we have our C code. Notice we have our GTK included because we had to explicitly include that. And the whole thing just sets up, and it's relatively not that bad, because all of it's dependent on GTK, and GTK is pretty smooth. So there's our example for that. And so the example here is we just have hello world, where it just prints out, and this is our code right here. This is it. This is our Vala code, and when we compile it through Vala C, this is what we get. And this isn't even all our code. In fact, it's only about half our code. If we wanted to really look at it, and we can, let's take a quick look. I actually have it set up, I believe. Yeah, so it's huge. But you know, we're not here to write simple, you know, hello world programs. We want to make it more complex to that. So this won't all go for waste when we're writing our, you know, real programs.
With these next few slides, we will go over the more unique and experimental features of Vala. This feature here is chained relational expressions. Chained relational expressions, which I'll call CREs from here on out, help to eliminate much of the redundancy that occurs when writing lengthy relational expressions. Instead of having to write out multiple double ampersands or double lines, CREs simplify complex relational expressions into a single, more natural expression. In addition to making the programmer's job easier, CREs also make the code much more easier to read and to understand. Still, CREs are an experimental feature, so attempting to chain together some varied expressions may result in a multitude of errors and bugs.
So strict non-null modes are what immutable values are to F#, and we only need to include a library for this to work, and then we have a working of immutable values like F# does. If we want to be able to make them mutable, then we have to simply state that the object is mutable with a question mark, as seen here after the object. Now if we try to override O1 with O2, it won't be able to do that because of immutability. But if we wanted to be able to do it, then we'd have to make an explicit non-null cast with an exclamation point in the assigning of the value, as seen right here.
Contract programming is another one of Vala's experimental features. What contract programming does is that it allows the restriction of the values of a method's parameters. It is also able to limit the return value of a method as well. This is a cool feature because it helps to enforce stronger security. If someone tries to manipulate your code, contract programming provides another level of protection.
For Vala IDE support, in Windows and Mac, you can use Valima and Vala IDE. Those easy Google search will find you those. For Ubuntu and Linux, you want to use the terminal and use the command sudo apt-get install, and then the two following upgrade and update. It'll be crucial for the next piece. And then you want to visit their website, their webpage for help.ubuntu, where basically they'll show you how to do it step by step. Other ways you can use it is through NetBeans, and there's a Vala plugin for that, and Valencia, which is a plugin for Get It. And for the official webpage, please visit this. And with that conclusion to our video, here's our bibliography, much small and simple. Any questions you might have regarding Vala or things not covered in the topics, let us know. And we hope you enjoyed our video, and thanks for watching.